Good morning, students. Let us copy the link given in the first slide and paste it on the browser and watch the video. Hope all of you will be liking it. In this slide, we are seeing few GIFs and few still photos. The first two GIF is showing two alarm clocks. The third one is very interesting, which is very much related to the previous slide, the video shown in that slide. Here it is showing a photo finish of Michael Phelps and Kevik. And the fourth photograph is of a timetable where the days of a week are mentioned and the time is mentioned for every period. Next photograph is an advertisement of a watch, and the last one is a sundial. Can you tell me one thing? What is coming to your mind after seeing this second slide? Yes, we are talking something about time. Time is the common thing in all the pics given here. Have you ever thought, if we did not have a clock, how would we decide what time of the day it is? We are very much dependent on electrical and electronic gadgets. But when clock was not there, how people used to find time? Have you ever wondered how our elders could tell approximate time of the day by just looking at the shadows? How do we measure time interval of a month and a year? For measuring time, we need something that repeats itself at regular intervals. The earliest method of telling time was the position of sun in the sky. So it was found that the sun rises every day in the morning. The time between one sunrise and the next sunrise was called a day. Similarly, a month was measured from one new moon to another new moon. A year was fixed as the time taken by the earth to complete one revolution around the sun. Often we need to measure intervals of time which are much shorter than a day. Clocks or watches are the most common time measuring devices, as we all know. Let us discuss about sundial. This is an ancient device to measure time by using the position of sun and the respective positions of shadows. The decrease and then increase in the length of shadow during the daytime was used in sundials to measure time. The sundial is placed in open sky in such a way that the gnomon points are in the north-south direction. The shadow of this gnomon on a circular scale shows the time at some particular moment. In our country, we have some ancient sundial. Maharaja Jai Singh was a great Indian astronomer, architect, and mathematician. He designed Samrat Yantra, which is a huge sundial. This can be seen in Jantar Mantar built by him at Jaipur, Delhi, Ujjain, and Varanasi. Its accuracy is up to half a minute. However, it does not work after sunset or on a cloudy days. Now we'll discuss about sand clock. Romans used sand clock which works on the principle that all the sand from the upper chamber falls into the lower chamber in a fixed interval of time. This fixed interval of time was the unit of measurement of time, commonly known as hour, and the sand clock was known as hourglass. As the upper chamber emptied completely, the hourglass was turned upside down so as to further record time. Now, what is time? Time is defined as the gap between two events. The gap between two successive nodes is taken as unit of time, and it is called a day or a solar day. A solar day is divided into 24 equal parts and each part is called an hour. 1 hour is further divided into 60 equal parts and each part is known as 1 minute. 1 minute is further divided into 60 equal parts and each part is called a second. The smallest time interval that can be measured with commonly available watches and clocks is 1 second. Special clocks are available that can measure time interval as small as 1 millionth or even 1 billionth of a second. These clocks are used for scientific research and in sports. 1 millionth of a second is known as 1 microsecond and 1 billionth of a second is known as 1 nanosecond. On the other hand, times of historical events are stated in centuries or millenniums. Now, what is the SI unit of time? The SI unit of time is second. Please note it, the SI unit is second, not hour or minute. Now, what is the relation between 1 second and 1 solar day? Let us calculate it. 1 solar day is equal to 24 hours. 1 hour is equal to 60 minutes and 1 minute is equal to 60 seconds. All this we have already discussed. So, number of seconds in 1 solar day will be 24 into 60 into 60, that is 86400 seconds. So, 1 second will be 1 by 86,400 part of a solar day. Now, how to convert the smaller unit into bigger unit? So, 365 days is equal to 1 hour, 10 years is equal to 1 decade, 10 decades is equal to 1 century, and 1 century is equal to 10 century is equal to 1 millennium. Now let us discuss about the instruments or devices for measurement of time. All the clocks and watches make use of some periodic motion. One of the most common periodic motion is that of a simple pendulum. There is an interesting story about the discovery of simple pendulum. Once, while attending a service in a local church, famous Italian scientist Galileo Galilei noticed that a lamp suspended from the ceiling of the church with a metallic chain was moving slowly from one side to another side and was describing a periodic motion. He was surprised to note that his pulse beat the same number of times during the interval in which the lamp completed one oscillation. Galileo experimented with various kinds of pendulums and verified his observation and made certain conclusions. What he observed on that day was that the time period, the time needed for a pendulum to complete one oscillation was almost same in all the time. So the conclusions he made was the pendulum of a given length always takes the same time to complete one oscillation. The time period of the pendulum of a given length is independent of the mass of the bob, and the time period of a pendulum increases with the increase in length. These observations led to the invention of pendulum clocks. Now we'll discuss about the motion of a simple pendulum. A simple pendulum, all of us have seen how it looks like. It consists of a small metallic ball which is known as bob, and it is suspended from a rigid support S by a light thread in the rest position. The rest position is denoted by A, that is position A. It is also known as mean position or equilibrium position. When the bob of the pendulum is taken to position B and released gently, it begins to move to and fro about its mean position. This to and fro motion of pendulum is known as oscillatory motion, and it is periodic in nature. That means it repeats after a regular interval of time. The pendulum is said to have completed one oscillation when its bob, starting from its mean position A, moves from position B to C through A and then back to B through A. The pendulum also completes one oscillation when its bob moves from one extreme position B to other extreme position C and comes back to B again. The time taken by the pendulum to complete one oscillation is called its time period. Let us do an activity to find the time period of a simple pendulum. This is our experiential learning. We'll be setting up a simple pendulum at its mean position A, such that the length of the thread will be about 1 meter. All the fans will be switched off as the moving air will affect the periodic motion of the pendulum. The mean position of the pendulum is marked on the floor with a chalk. In order to set the pendulum into motion, it is pulled gently to position B and then released. We have to remember, we will not be pulling or pushing the bob. We have to release it gently. When the pendulum performs a smooth oscillatory motion, we will start our observation. We'll take a stopwatch and the stopwatch will be brought to 0 position. When the bob of the oscillating pendulum comes to position B, the stopwatch is started. Position B is an extreme position. Remember that. So, the stopwatch is started when the bob is at one extreme position B. When the pendulum is going to position C and again comes back to position B, it describes an oscillation. Time is noted with a stopwatch when the pendulum completes 20 such oscillations. Time period of the pendulum is calculated by dividing the recorded time with 20. The procedure is repeated for 2 more times at least. Then the average time period is calculated by adding and dividing by 3. It is observed that the time period of the pendulum are nearly same. A slight change in initial displacement does not affect the time period of the pendulum. We'll make a table like this. We'll draw the diagram and there will be 3 columns First column is number of observations. We are having 3 observations, 1, 2 and 3. Second column is time taken for 20 oscillations. Whatever we are noting in stopwatch, we have to note it down. And then in the third column, we are calculating the time period of one oscillation. That means the recorded time is divided by 20 and it is calculated in second. This activity you will be writing down in your SAC notebook. Now we'll discuss about different types of clocks and watches. A pendulum of about 25 centimeter takes exactly 1 second for one oscillation. The pendulum in a clock swings continuously under the action of a wound-up spring and controls the movements of its hands. A mechanical wristwatch is shown in the second diagram. It does not have a pendulum. It has a balance wheel which serves the same purpose as pendulum and controls the movements of its hands. Nowadays, we are using electronic watches for measurement of time, and it is displayed either by hands or on a screen in the form of digits as shown in the photograph. For measuring short time intervals in athletics, stopwatch is used, which can be started or stopped by pressing a button and which measures time up to 1/10 of a second. Digital watches are also available in the form of stopwatches. Now let us discuss a critical thinking question on the concept. In the figure, we are seeing an oscillating pendulum. The mean position is O, one extreme position is B, then other two positions are C and A. The time taken by the bob to move from A to C is T1 and from C to O is T2. The time period of this pendulum will be, there are 4 options given. This is a question from NCERT exemplar. The first option is T1 plus T2. Second option is 2 into T1 plus T2. Third one is 3 into T1 plus T2 and fourth option is 4 into T1 plus T2. Which one will be the correct option? Now, two extreme positions are A and B. So, if for the movement of A to C, the time taken is T1 and from C to O it is T2, then the total time to move from one extreme position to mean position O will be T1 plus T2. Then for movement of the bob from O to another extreme position B will also be T1 plus T2. But time period means starting from A, through the position O it will reach B and then again from B it will reach A through O. So, it has to come back to position A to complete one oscillation. So, if the time needed to move from A to O is T1 plus T2, then the time needed to move from O to B will also be T1 plus T2. Then from B to O it will be another T1 plus T2 and again from O to A it will be T1 plus T2. So, the total time needed to come back to position A, that is time period, is 4 into T1 plus T2. So, D is the correct option. Learning outcome will be the students will be able to know about the ancient methods of knowing time like sundial and sand clock. They will be able to know about the SI unit of time, that is second. They will know about the conversion of larger and smaller units of time. They will know about the discovery of simple pendulum and the functioning of a simple pendulum. They will be able to identify an oscillatory or periodic motion. They will define time period of oscillation. They will be able to perform the activity to find the time period of a simple pendulum. And finally, they will be able to differentiate between the different kinds of watches and clocks. Thank you, students. Hope all of you had understood whatever is taught and discussed in these slides. Thank you again.